The B-52 Stratofortress was built to outlast the Cold War, and somehow, it's outlasted nearly every aircraft it once flew beside. 70 years later, this bomber is still flying, but now it's about to transform. A set of brand new Rolls-Royce F130 engines will give it more range, more power, and a future no one thought possible. These aren't upgrades, they're game changers, cutting fuel burn, slashing maintenance, and unlocking performance the B-52 has never had. But here's the shocker. The technology keeping this relic alive could also reshape commercial aviation. So, what makes these engines so revolutionary? Why did the Air Force wait decades to replace them? And how is a bomber designed in the 1950s still rewriting the rules of modern flight? Let's find out. On the runway, the B-52 looks like a powerhouse, but under the skin, it's been limping along for decades. The current engines, the TF-33s, first entered service in the early 1960s. They were never designed to last this long, and now, trying to push them into the 2050s, is catching up with the Air Force fast. Maintenance costs have skyrocketed. The service spends tens of millions every year just to keep the fleet operational. Spare parts are rare, sometimes impossible to find, forcing technicians to salvage and rebuild old components using Cold War-era workarounds. One example? Cart starts, where explosive cartridges are used to fire up the engines manually. It's noisy, outdated, and highlights just how old the system really is. Fuel inefficiency is another huge issue. The TF-33s burn through far more fuel than modern engines, cutting into range and adding massive logistical strain. They're also incredibly loud, not only a problem for stealth, but also a diplomatic headache during overseas missions. And the biggest problem of all? Risk. These engines are far beyond their design life. Every hour flown increases the odds of serious failure. That's unacceptable for a bomber that still anchors America's nuclear deterrent. By the mid-2010s, it was clear replacing the TF-33s wasn't just an upgrade, it was survival. The only question was what engine could modernize the B-52 without disrupting the entire platform. The answer came when Rolls-Royce won the contract to re-engine the bomber. The goal wasn't just to swap engines, it was to transform the jet's core performance. Enter the F130, a military version of the proven BR-725. But this isn't a simple copy. The F130 has been purpose-built to fit a 60-year-old airframe while delivering state-of-the-art performance. The first major win? Fuel economy. Compared to the TF-33, the F130 is expected to burn up to 40% less fuel. That's a massive gain, extending range, reducing tanker demand, and cutting costs. Then there's reliability. The F130 was designed for long service life with fewer overhauls, predictable maintenance, and less downtime. For a plane expected to fly into the 2050s, that's non-negotiable. And of course, thrust. Each F130 produces about 17,000 pounds compared to just 12,000 in the TF-33. That extra power boosts takeoff, climb, and high-altitude performance, especially in hot or demanding environments. The first big systems test came at NASA's Stennis Space Center, where Rolls-Royce successfully ran a twin-engine pod, just like the setup on the real B-52. The next milestone will be high-altitude testing at Arnold Air Force Base in 2025, simulating real-world flight conditions. Now here's where it gets really interesting. While the F-130 was built for the military, its design has clear commercial crossover potential. That's because it shares DNA with the BR-725, itself part of the Rolls-Royce Pearl engine family, already powering luxury business jets like the Gulfstream G700. The F-130 packs an ideal balance. Compact enough to fit legacy mounts, yet strong enough to deliver 17,000 pounds of thrust, while still meeting modern emissions and noise standards. Exactly what airlines are hunting for in future propulsion systems. Behind the scenes, Rolls-Royce pushed innovations across multiple fronts. The F-130 uses advanced materials that boost thermal efficiency and resist wear, meaning engines can run hotter, last longer, and need fewer inspections. That's gold for both military fleets and airlines. It also comes with updated digital controls. The FADEC system precisely manages fuel flow, optimizes thrust, and enables predictive maintenance. This tech is common in new airliners, but adapting it for a bomber built in the 1950s forced engineers to find creative efficiencies, solutions that could spill over into civilian aviation. Looking further ahead, the lessons learned here could shape the next generation of commercial turbofans, from lighter cores and quieter fans to sharper digital integration. Military innovation once again, speeding up civilian progress. Upgrading the B-52 isn't just about engines. By the time the program is complete, the aircraft will receive a brand new designation, B-52J. Alongside the F130S, the bomber is getting a new AESA radar and several other modern systems, making it one of the most ambitious modernization efforts in Air Force history. This upgrade gives the B-52J a sharper view of the battlefield, with improved targeting, tracking, and protection against electronic warfare. It's a massive step forward compared to the analog radar still flying today. To support that leap, the bomber is also getting a fully digital backbone, new mission computers, modern communications gear, and advanced data links. These systems will allow the B-52 to plug directly into the Joint Force network, sharing and receiving targeting information in real time. But modernization runs deeper than avionics. Just installing the new engines demands redesigned pylons, fresh wiring, and structural reinforcements across the wings. This is no plug-and-play swap. The B-52 was designed in the 1950s, so every change requires careful analysis to keep the aircraft safe and effective. Boeing and Rolls-Royce are relying heavily on digital modeling to make it happen. Using digital twins and simulation tools, engineers can predict stress points, test airflow, and confirm system integration long before physical prototypes are built. It's modern aerospace engineering applied to a Cold War airframe. Even with those tools, the program timeline has slipped. Initial operating capability was once set for 2030. Now that date has pushed to 2033. According to the Government Accountability Office, the delays come from underestimating cost and complexity, especially in rewiring and integration. Still, progress continues, and when it's done, the B-52J will be far more than a re-engined bomber. It will be a reimagined weapon system designed to serve deep into the 2050s. For all of this to work, the Air Force needed more than technology. It needed reliable production. That's why every F130 engine is being built in Indianapolis, at Rolls-Royce's largest U.S. facility. This plant has become the center of a $600 million investment, equipped with new automation, precision tools, and high-performance testing bays to handle the B-52 program. The impact is already being felt. Over 1,000 American workers, from engineers to machinists, are tied to the project, and the ripple effect spreads further. The F130 supply chain includes dozens of small and mid-sized companies across the United States, feeding materials and parts into production. In other words, this isn't just defense spending. It's an economic boost for communities nationwide. Every engine rolling off the line supports hundreds of American jobs, from raw material processing to final testing. And it doesn't stop there. These engines will need decades of support, ongoing maintenance, performance monitoring, and software updates, all feeding back into the same U.S. industrial base that built them. That means long-term sustainment jobs and a stronger domestic aerospace sector. For lawmakers, it's a win-win. The Air Force gets tighter control over logistics and timelines, while local economies benefit from advanced manufacturing jobs. For Rolls-Royce, it's a chance to strengthen its role in U.S. defense, while showcasing technology that could shape future commercial engines. Other countries are taking notice. What started as an American bomber upgrade is now seen as a global case study. If a 1950s bomber can be modernized instead of replaced, what about older transports, surveillance planes, or maritime patrol aircraft? The appeal is obvious. New aircraft programs are expensive, politically risky, and often plagued by delays. Retrofitting offers a cheaper, faster alternative, extend the aircraft's life, boost performance, and save money. There's also a new strategic angle. Sustainability is becoming part of defense planning. Instead of scrapping still useful airframes, the B-52J shows that you can revive old platforms with modern engines, sensors, and systems. The result: lower emissions, longer range, and much better fuel efficiency, all while keeping the aircraft combat relevant. The U.S. Air Force plans to fly the B-52J into the 2050s, working alongside the new B-21 Raider. The division of labor is clear. The B-52 handles long-endurance missions, while the Raider focuses on stealth penetration. By upgrading instead of replacing, the Air Force avoids the cost of fielding an entirely new fleet. This model, keep what works, upgrade what matters, is now being studied by militaries worldwide. Not because it sounds good, but because it's practical, cost-effective, and sustainable. At its core, The F130 engine upgrade gives the B-52 new life, better fuel economy, easier maintenance, and reliable power. But its influence may stretch far beyond the Air Force. Engine makers, airlines, and foreign governments are all watching closely. The B-52 may have been born in another era, but its next chapter could reshape how aviation modernizes, not by starting over, but by building smarter. And if you enjoyed this deep dive into the past, present, and future of aviation, don't forget to like the video and subscribe for more.